Uniform circular motion. Physics 101. Remember, the uniform circular motion is the motion of a body in a circular path. But the point you should note is it is happening at constant speed, but varying velocity. And here we are interested in actually the calculation and the formula involved in this uniform circular motion. Now remember that we have that the velocity is 2 pi r all over t. And if the velocity is 2 pi r all over t, you already know that the pi is 22 all over 7, or is equal to 3.142. And remember, you cannot talk about why r is the radius and t is the time or period. And remember, you cannot talk about circular motion without talking about centripetal force and centripetal acceleration. Remember, for the second law of motion, that F is equals to what? Ma, right? And under centripetal force is mv square all over r. Now, remember, if this is the formula for centripetal force, that means that A is equals to V square all over R. If this is my equation 1, this is my equation 2, and this is my equation 3. Now look at what I want to do. Let me call this equation 4. Now I want to put equation 4 into equation 3. I want to put equation 4 into 3. That means wherever I see V, I will remove it and replace it with 2 pi r all over t. Therefore, what it means is that your acceleration will now be equals to 2 pi r. Remember, it's all in square, right? All over r, all over t. Now, the next thing I'm going to have to do is, no, I made a small mistake here. This should give me 2 pi r all over t all over r. Now if I open this bracket, what I will get is 4 pi square r square all over t all over r. Now of course this will cancel this, so therefore the centripetal acceleration is 4 pi square r all over t. Now, why I'm trying to waste my time improving this formula is I'm going to be using it a lot in various calculations. A lot. Please remember, this is I forgot that this one include here and here, right? And so this is 4 pi r square, and here should be t square. So this cancel this should give you like this. So the formula for centripetal acceleration is 4 pi square r all over t square. Now, please, I'll be solving a lot of calculation under this. So let's go to the question calculation under this proper, please. Now we are back. The first question here is: the Earth revolves around the Sun once a year in a circular path of radius 9.3 times 10 to the power of 7 miles. The question is: calculate the initial speed of the Earth. And the second one is the magnitude of the Earth centripetal acceleration. And that is the reason why I wasted time trying to prove this. Now, of course, via solution, what I'm going to do is that we are going to use this equation at the board and solve it. Now, you already know this. Let me clean this part. Remember, we said that V is equal to 2 pi r, the radius. Now, the period, the time, it revolves around the Sun once a year. And so, I have to calculate my period, which is 1 year, right? Now, 1 year. Now, in a year, we have 365 days, right? And in a day, we have 24 hours. So I want to convert year to hours. If you don't know how to do this conversion, check my video on conversion factor, please. And then this is 1 times 365 in a year. For now, it's in a year. How many hours is in a day? So this is 1 year, and in a year we have 365 days. And how many hours is now in days? We have 24 hours, right? So I want to stop here because I want to convert it to hour. So from a year to hour, and that will give you a total of 8760 hour, right? Good. Now the next thing is for me to get my R, and the radius is given in miles. So all you need to do is I'll just put this in and my answer will flow naturally. So from here we have 2 pi r all over t, and so this is 2 times 3.142 times the radius is 9.3 times 10 raised to the power of 7 all over 8760, and that will give you an answer of 6.67 times 10 raised to the power of 4 miles per hour. Remember, this one is given in miles, so this is mile per hour. Why I converted this in hour? So this is my answer in miles per hour. Now the next one is they ask us to calculate the magnitude of the Earth centripetal acceleration. Remember, I just proved that this is equals to 4 pi r 4 square r all over t square. If you want to use this, you can use this. But if you want to also use this one, that centripetal is v square all over r, you can still use it, you still get the same answer. And so let me use the easier one, which is this. It's equal to v square all over r. So all I need to do is 6.67 times 10 raised to the power of 4, already calculated. Remember, all in square, divided by radius, which is 9.3 times 10 raised to the power of 7. And so my centripetal acceleration will now be 47.84 miles per hour square. Remember, the SI unit of velocity is distance over time, which is meter per second. The SI unit of acceleration is meter per second square. So the same thing is happening here. This is mile per hour, while this one is mile per hour square. Please always note the SI unit while solving physics. Very important.